She really is quite sexy. I think I'm in love. It's a shame you suck at flying. It's much more scale than the other park flyers. Little bigger as well. When you gonna let me fly it? Probably never.
Third in a series of park flying pushers is the F-15 Eagle. This 3D printed F-15 can be built with or without a clear canopy, and has several different control options, which I will get to in a minute.
The ailerons are backwards. They can't be! I followed the build video! Yeah, but you're an idiot.
The Elevons are backwards too, dumbass.
It will still fly just fine, okay?
Are the rudders right at least?
Nope! You know what? I don't like your attitude.
Have you ever seen an F-15 that's capable of flying like it has vector thrust? Well, now you have, thanks to the very unique flight characteristics of these pusher park jets. In fact, they're consistently my go-to aircraft when heading out to the field.
Oh great, another EDF that's incredibly hard to hand launch. It's a prop jet. They are much easier to launch.
Which is one of the things I really love about these park jets. They're very easy to get airborne. Unlike an EDF, you don't need a strong throwing arm. Actually, you don't even need arms. Here I use my feet just to show you how simple it really is. In fact, you don't really have to throw them at all. Look at how easy these jets are to get airborne. Basically just throttle up and let go.
How do you want me to throw this thing? I don't want to break it. I don't care. The idiot on YouTube launched it with his feet, so it can't be that hard. I'm not doing that. Remember the A4? Just throw it into the wind.
Each one of these Park Flying Series models are incredibly fun to fly. And although they each fly a little differently, they're all very easy to lock into high alpha. You can just about hover them as well.
How should I know which way the wind is blowing? With the wind or into the wind? Is there a difference? Throttle up before release or after? How about during release? I would like to keep my fingers. I'm not doing it. You throw it.
This F-15 can be built with as little as 2 servos and a mechanical 4x4 setup. Or for advanced pilots, you can add optional flaperons, spoilerons, and a single or dual rudder.
I'm going to show you step by step how to assemble this park flying pusher, also known as the Eagle with options. It's so easy, even a human could do it.
Even though these park flyers are extremely easy to print and assemble, especially without the use of any hinges, this video will hopefully answer any questions you may have regarding the build. We'll cover servo setup, which motor and prop to use, and even 2 simple to replicate paint schemes to really make the model stand out among others.
The drone motors in the KV range of 15 to 1900 work equally as well. Subscribe for when I weigh pros and cons of different drone motors in these printed park flyers.
Here is the only drone motor you'll see in this entire video, running on 6S with a 7-inch prop, capable of sustained hover at only 45% throttle. What I did here was stupid. Don't try this at home.
Personally, I like to overpower mine. If you have any questions about your motor and prop, don't hesitate to drop a comment. If you're unsure whether or not that motor and prop you have lying around will work, drop a comment below.
Choosing to strengthen your model with optional carbon fiber or cheap steel yard flags will help make them very resilient to minor crashes. Here's where the gray F-15 acquired its snub nose. And here's where it got its clipped wing. As long as you don't put it full throttle straight into the ground, chances are it'll still be flyable. The smoke bombs actually did more irreversible damage than the few minor crashes.
I'm ready whenever you are.
Oh yeah, forgot I'm supposed to be training you.
You're such a transmitter hog.
On a windy day, you can even get them to fly backward if you're good enough. If you'd like to see magnetic drop tanks, and possibly even removable armament, help me reach 1,000 likes on this video. Otherwise, look out McDonnell Douglas, because even a garage full of gorillas can achieve full air superiority right off their printer. Alright, I think I've had about enough monkeying around for one day. What do you say you let me show you how to build one of these for yourself?
Let's start the build by prepping all the fuselage parts, clearing all the holes of any obstructions. Make sure the tabs on the back of fuse number 5 move freely, as they will hold servo wires later. Decide whether you want to use optional carbon fiber or steel rods to reinforce your model. Insert 3 rods into fuse number 2, then guide them forward into fuse 1, keeping them forward as much as possible at all times. Apply medium or thick CA and slide both parts together. Align them as best you can before using accelerator. Now do the same for fuse number 3. Apply a generous amount of glue and carefully guide fuse 3 into place. Those rods will strengthen the battery compartment and will help prevent the nose from breaking off in the event of a crash. While maintaining forward pressure, wipe off any excess glue and hit it with accelerator. Next, glue fuse 4 into place. The next 4 rods that run the length of the fuselage can be inserted at any time, and they will greatly help you to align the parts. They also strengthen the model and limit the amount of infill used. You can do this in whatever order you're most comfortable with, although it is easier to have the rods in place before applying any glue. Verify all 4 of them are seated as far forward as possible before continuing. Wipe off any excess glue and pay special attention to the wing saddles. Make sure the left and right sides of the fuselage are as flush as possible to avoid having a gap when we install the wings. It's easiest to tack down one side, tack down the other side, then go over the entire thing with accelerator. Moving on to fuselage number 5. Apply glue to fuse 5 and guide it into place. This is why it's easier to guide the rods into the parts before applying any glue. Just like before, while maintaining forward pressure, verify each wing saddle is as flush as possible. Again, tacking down each side one at a time. Now that fuse number 1 through 5 are assembled, let's set that aside while we assemble fuse number 6. Using 2 pieces of carbon fiber solely as a guide, align fuse 6 and fuse 7L. Apply glue, slide them together, and align them as best as you can before using accelerator. Once you're done, remove the carbon fiber and set them aside. Repeat this for the right side. Align fuse 6 and 7R using 2 rods and glue them together as flush as you can. When you're done, remove the rods for the final time. Next, verify both stab inners are oriented correctly and glue them together. They should come to a V as shown here. Notice the deep depressions in the left and right sides of the fuselage parts. This is where the stab will rest. Apply glue to the stab and seat it into one of the fuselage recessions. Maintain inward pressure while making the back of the stab as flush and as straight as you can. Repeat this same process for the other side. Apply glue and seat the stab into its recession. You will feel it lock into place. Verify the rear of the stabs are as flush as possible. It helps to tack down the rear, get all the parts as straight as you can, then apply accelerator. Now that fuse 6 is assembled, let's mate it to the rest of the fuselage. You'll notice 4 cut lines on the fuselage parts. This will help indicate how far back the rods will go. Cut them about 1/4 inch short. Check your fit, then apply a generous amount of glue to both sides of fuse number 6. While maintaining forward pressure, wipe off any excess glue and align them as best as you can before applying accelerator. Now that the fuselage is completely assembled, let's start on the hatch. After gathering all the hatch pieces, you can use 2 short rods to join hatch front and hatch rear. Apply glue, slide them together, and hit it with accelerator. Next, drop the slide lock into hatch front like I did here. Use just a small amount of glue on the outsides. Then insert the lock holder as shown. Add extra glue to the outside of the lock holder and hit it with accelerator. Try to keep the slide lock moving until the glue hardens completely. Lastly, glue the rear hatch pin into place. Stick a small rubber band on it and let's check to see how it fits. Perfect. Now for the Elevons. Glue each Elevon inner and outer together using the table to help align them. Do this for both the left and the right side. Insert a steel wire into the hinge line and clear out any glue you may have introduced. This will make hinging the Elevons easier later on. Next, gather the parts for the vertical fins. Notice the servo pocket and the control horn are both on the outside right of the airplane, while the tabs to tie the rudders together are both on the inside. Using a short wire as a guide, glue fin bottom to fin top. Repeat this for the other side as well. The model also comes with files to print the V-fins whole without rudders. You could also use 2 servos if you like, but this is the recommended setup. Set them aside for now and let's get started on the wings. Wing 1 and Wing 2 can be printed either separately or whole depending on your bed size. I prefer to print them together when I can. Start by prepping all the wing parts to make sure the holes are free of clogs. Now insert the carbon fiber or steel rods that will help strengthen the wings. Using a generous amount of glue, slide the wing onto both rods and into place. Standing the fuse up on its side will help keep the wing from sagging as the glue hardens. Align the front and back as best you can. Clean up any excess while holding it in place and hit it with accelerator. Apply glue to the outside of the wing and install wing number 3. Here I use the table to help align the wing parts. Install the right wing using the same procedure. Don't be stingy with the glue, it's only the wing. Slide the wing into position, maintain inward pressure and spray it with accelerator. Tack down the front and back separately if it helps, before going over the entire wing. And finally, apply glue to the outside of the wing and install wing number 3. It's now safe to cut the steel or carbon fiber to length. Locate both stab outer pieces and glue them in place. The rear of stab outer should be flush with the back of the elevator, and the front should overlap. This is how the stab on the real F-15 is. Glue the other stab on in the same manner. Now we can hinge all the control surfaces. Hinge each aileron by guiding printer filament through the hinge line until it reaches the fuselage. Leave excess filament hanging out of each side so we can remove the ailerons to install the pushrods. You do not need to glue the filament in place. Hinge the Elevons using this same technique. You can use either one single piece across both Elevons or hinge them both separately, whatever is easiest for you. Here I installed them with one piece. You do not need to glue the filament hinge in place. Look at how easy the control surfaces move with this technique. Plus, it's very easy to install. Install Velcro for the battery, ESC, and receiver. I like to use glue on the outside of the Velcro to keep it from lifting. A 2200 4S battery will sit approximately here if you followed the print recommendations. Now gather your electronics, bind your receiver, and center your servos.
DSMX 22 milliseconds. Bind complete.
Set the fuse aside and gather your motor and mount. Since this airframe is a little bigger than the other Park Flyers, we're going to install the larger 2836 1500 kV aircraft motor. We'll use the ASA motor mount that comes with the files and a 7053 bladed prop. Subscribe for a video where I weigh pros and cons of different sized drone motors, some of which are capable of 6S using 7-inch props of progressively larger pitches. There are mounts for an initial installation or if replacing the aircraft motor. Start by mounting the motor to the ASA motor mount using 4 M3 sized bolts and nuts. Thread all 4 bolts into the mount. After more than a dozen installs, this is the easiest way to install the nuts. Using needle nose pliers, thread all 4 nuts onto the bolts. Tighten all 4 with pliers or a socket wrench. Attach a 50 or 60 amp ESC and check the polarity of the motor. Drop the ESC and motor assembly into the back of the fuselage. Cover the motor mount with glue on all sides. Spread it around by sliding the mount forward and aft. Leave the mount rest flush with the back wall of fuse 5. Carefully center it both horizontally and vertically, then apply accelerator. Now to install the servos. The 2 forward pockets will be for an advanced spoileron, flaperon setup and won't be used in this particular build.
Landing flaps.
The 2 aft pockets will be for the recommended Elevon and mechanical 4x4 setup. The 4 holes here in the center would be for the optional and ugly centerline rudder, which won't be used in this particular build. This is the easiest way to guide the servo wires, so pay attention. Guide each servo wire through its channel and pull it out the back of the intakes. Feed a servo extension through the fuse and also out the back of the intake. Then connect both wires together and pull them forward into the battery compartment. You can do this trick for all 4 servos, and it definitely makes it a little easier. Plug everything into your receiver and center your servos if you haven't already. Now measure and cut 2 pieces of 18 gauge or stronger music wire and bend them to the shape seen here. Install each Elevon pushrod using the 4th hole in your 9-gram servo. Removing the servo arms will make this task much easier. Do this for both Elevons, keeping them as even as you can. Now bend and cut 2 pieces of wire for the Ailerons. Bend them similar to the shape seen here. In this build, I used 18 gauge music wire for the Elevons and 20 gauge for the Ailerons. But you can use stronger wire if you like. Remove the filament hinge for one of the Ailerons. Install the Aileron pushrod using the 3rd hole in the servo arm. Reinstall the aileron by rehinging it with printer filament. Always give the ailerons less throw by installing them 1 hole inward of the Elevons. Let me show you that again. Remove the hinge. Install the aileron pushrod. Then rehinge the aileron. This method is extremely easy and very effective. It's now safe to cut the filament to length. Don't forget about the screws for the servo arms. Next, tack down both servos using hot glue. You can glue them in so the Elevons have 4 millimeters of up elevator, but that can easily be done with trim later. It's a good idea to only apply hot glue where you can access it with an X-Acto knife. This will make replacing the servos easier if something goes wrong. Check the function of your mechanical 4x4 setup by verifying the pushrod ends don't come in contact with each other when the control surfaces move. If either of them touch, simply bend them out of the way. Grab a vertical fin we assembled earlier, dry fit it into the fuselage and cut the rod to length. Cut the other one as well. Drop a 9-gram servo with extension into the pocket and screw it into place. You can use printer filament to hinge both rudders, but using carbon fiber or steel to hinge them will help add additional support to the vertical fins, and is the recommended method. Leave plenty of excess on the bottom so it can be inserted into the fuselage. Using 18 gauge music wire, measure and bend a pushrod for the right rudder, and install it into the 4th hole of the servo arm. Next, glue both vertical fins onto the fuselage. You can do this with or without the rudders being pre-hinged. It's okay to glue the leading edge rod into place, but don't apply glue to the hinge line rod just yet. Now connect the rudders together using another piece of 18 gauge or better music wire. Bend it similar to the shape seen here. Insert the interconnecting rod from the bottom up. You will need to remove at least one of the hinges to be able to install the rudder connecting wire. Once you're happy with the function of the connected rudders, trim off any excess hinge material. You can apply a very small drop of glue to the top of the hinge to keep it from backing out. Route the servo wire through the aft intake and tuck the excess behind the clip. This will help keep extra wire away from the prop. Be sure to tack down any exposed wire in this area with hot glue, especially before running the motor. And finally, install your prop. Before flight, verify your control surfaces are moving in the correct direction. Now let's radio mock and get a crew chief to tow the aircraft to Paint Barn. After mixing a lot of white, some blues, and a little black, this first paint scheme was super easy to apply. Hand brushing printed models with water-based acrylics is by far the quickest and easiest way to make them stand out in the sky. The Emerald Knights, 308th Fighter Squadron, green and white checkered pattern was printed on regular paper, after which I used Mod Podge to glue it to the vertical fins. This entire paint scheme took about 40 minutes and was well worth it. Now that the model is completely done, let's throw it on a scale. Printed using the provided G-codes without the clear canopy, with Color Fab's lightweight PLA. Built with the recommended servo setup, using a 2836 aircraft motor and 60 amp ESC, reinforced with a combo of steel and carbon fiber. The model came out to about 825 grams when weighed without a battery. The Air National Guard American flag paint scheme was easier than it looks. It's actually a real paint job. Start by printing the wings and tail surfaces with white filament and fuselage in all black. Mask off all the white pieces so you can apply red spray paint. Here I masked each stripe, 2 tape rolls wide just to keep it simple, and only painted the top of the wing, which will help with orientation. Once painted, carefully remove all the tape. The assembly procedure for the painted parts is no different than what I already showed you. Use masking tape to make a straight line and paint the top and bottom of the nose blue. Add any other details you want. Now would be a great time to install the clear canopy. Next, I cut out a bunch of stars, about 6 at a time, on normal white office paper. Place them approximately where you want them and use Mod Podge to glue them into place. Cutting and placing the stars was the most tedious part of this paint scheme. I did not apply stars to the bottom of the fuselage. If you can find some stickers the correct size, it may make this part easier. After the stars are all placed, go over each of them with extra Mod Podge. This F-15 now looks absolutely beautiful and will definitely draw attention at the field.
Landing flaps. Spoilers.
The spoileron and flaperon setup using 5 servos weighs about 930 grams. The mechanical 4x4 setup using 3 servos came in around 825 grams. Both aircraft have the same motor, same ESC, and same infill percentage. If you've enjoyed watching me build this F-15, drop a comment and give this video a like.